नहीं कर रहे सर, कर रहे हैं बट okay. Very good morning everyone. Audio is fine. So today you should not feel sleepy. Okay. See, in the previous session we started discussing the glacial landforms and we have seen the erosional landforms. They are created by the erosional activity of the glaciers. What are glaciers? They are simply big ice blocks. So when they move down the slope, either due to gravity or due to increasing temperatures or any other reasons, they are going to cut some erosional features. So they might drag some areas and create a erosional landscapes. So some of them we have seen like Kori, Arite and Horn, etc. Now we will look at other erosional landforms. So next please put the heading, that is glacial trough. Glacial trough. First understand it, then we will write it. Okay, let's say here I have given a landscape of a glacial region. Now let's say all these mountains are filled with glaciers. Just for the convenience the brown color is there, but imagine it is the white color of the snow. Now this halo basin is what we call, whenever there is a glacial erosion, whatever the halo basin that is cut here, 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 what are they called? Corrie. Now between two halo basins the ridge is called arete. When such ridges, like this is one ridge, now in this image even you can have a clear picture, like when this ridge, all these ridges are meeting to form a kind of a pyramidal peak, a cone, that is what we call it as horn, because it appears like a horn. So these are the three things we have learned. Now let's say when such glaciers are like they are cutting and they are moving, and all such glaciers, let's say this glacier, they will move, and when they move they will cut valleys. Like let's say a huge block of ice is there, now the ice is moving down the slope, that means along the slope it is going to drag. So as the drag is happening, because of its weight, it is going to erode some material and create a kind of path. True or not? Yes. When that happens multiple times, let's say on this surface when one glacier happens, another glacier, when they are continuously following the same path, every time when they cut or when they erode, there will be a kind of depression created. And when this happens for a long period of time, see here in this surface there will be a halo basin cut. Okay, for example all the glaciers which are coming from here, see they will be coming, the ice blocks will be coming from here, then they start going through this region, and as a result of it, in this entire region they will create a valley or a depression, a big depression. This big depression is what we call it as glacial trough. Clear? Very good. Right. So that is a glacial trough. In simple sense, it is a kind of a depression cut by repeated movement of glaciers. Now here there can be bigger ones, there can be smaller ones. Okay. Now let's say here this is the big one. I think it got frozen. Okay, there is some issue with the pen. Okay, now it's working. Yeah, so there was some lag, but now it's working. Okay. So when these glaciers are continuously flowing through it, they are cutting a deep depression. That depression is what we call it as glacial trough. Now let's say the glacier is not big enough and it is not able to cut a deep depression like the glacial trough. There can be smaller ones, right? Such smaller ones, they are going to make a small valley, right? Let's say here there is a ice block. There is some issue with this pen, maybe the battery is down. Just a second. Connection error or something is there. That's the reason. Okay. We are talking about smaller glaciers. So smaller glaciers, when they move, they are going to cut the valleys, same action, but the valley is going to be smaller. It's not deeper, it's not larger, because it doesn't have that much of power. So then what we are going to get is a kind of a valley which appears, let's say you are in this depression, to you it appears that this valley which is created by smaller glaciers is hanging at a height. True or not? If you look at this, you can appreciate it. Let's say you are here in the depression, to you this valley, this valley, this valley, this, all of them are depressions or valleys are cut by the glaciers, moving glaciers, but they are smaller depressions, not large enough, because the glacier is small and it could not do that much of erosional activity, and ultimately all the glaciers which are flowing through it, they have come here and they started cutting deep here. That's why it has become a bigger one. So the bigger one is called glacial trough, and the smaller valleys which appear like hanging at a height, they are called hanging valleys. Okay, and through that hanging valleys, sometimes even the water which is melted from these glaciers can pass. You can see here there is some waterfall kind of streams coming from these hanging valleys, right? They are going to further cut and make that valley further deep and give more relief related to that hanging valley. So these are two more features related to the erosional activity of glaciers. Okay, so please write glacial trough. Yeah, Akash, I remember. Okay, hanging valleys are always perpendicular to glacial trough. In a sense, you can say, because if the glacial trough is kind of this kind of depression, now imagine here somewhere there is another valley which is created by the glaciers coming from upper stretches of the mountains. As a result, there are series of, let's say here, you imagine there is a valley created by some glacier coming from the mountain, and all those glaciers fall into this area and they flow and they cut here, create a deep glacial trough. So this diagram itself can suggest how they are created. Clear? So please write glacial trough. It is a steep sided, flat bottomed valley, so inside bracket you can write U-shaped valley, which is cut by the erosional activity of glaciers repeatedly. Glaciers repeatedly. Done. Now we can also look at the hanging valley. Please put the subheading. Then diagram, both we will represent in one diagram. Okay. Please put the subheading, hanging valley. When smaller glaciers or rivulets, unable to cut as deeply as bigger ones, the valleys created by them appear as if they are hanging at a height. Such valleys are called hanging valleys. See here, there is a mentioning of discordant river or discordant tributary. Don't worry, we will cover it. When I enter into Indian river system, there I will mention what are discordant rivers, what are concordant rivers, what are the sub classifications within them. A discordant river is something which is not going to follow the topography, like underlying topography. It is going to flow irrespective of whatever the changes that happen beneath. Such a river is called discordant. They generally create the hanging valleys and gorges and other things. We will discuss about them. Okay, don't worry if the new term is there here. Okay, this we will connect it there, then I will make you remember this is what we have seen it in the hanging valley. Okay, so these are all some of the erosional landforms: Corrie, then Arite, Horn, glacial trough and hanging valley, etc. Now let us see what are the depositional landforms that are created. See, these are out of these depositional landforms, some of them can be the action of both deposition and erosion, but deposition is predominating, that is why we have kept it here. So let us try to look at them. Okay, first please put the subheading, that is depositional landforms, and within that the first category is outwash plain. See, this is also called till plain. See, when we say outwash, what does it means? Outwash or washed out. Oh, diagram. You have not written the diagram, right? Sorry, I forgot. You can present it, like this diagram can be added. If you have space, please add it. See, just to give the three dimensionality, that's why I am drawing it like this, but you can also draw two dimensional. The point is to convey what we have understood, so we do not have to worry much about it. This is where we will be showing the hanging valleys. If you want to put, you can put a glacial mountain or a rock with corries, okay, arites. Okay, here there is this stream which is cutting these valleys. Okay, now this is what we call it as glacial trough. and these ones like this, this and this is a hanging valley. Thank you Akash for reminding the diagram. Done. Now we can look at the depositional ones. Please put the heading, that is depositional landforms. Out of them, first one is outwash plain. Diagram is done. Why sitting at a very far distance? Why don't you sit here? Then I may have to put less efforts to reach to you. Otherwise, I have to shout and explain. Is there any issue sitting near? So please come. I am very friendly. Please come. You also, you can come and sit here if you are comfortable. Sit at a distance where you have the comfort of the screen. Okay. Online people, they are sitting at their comfort already, so nothing to worry about them. Screen is fine if you sit here. Screen will be fine if you sit here. Okay then. Okay, let's learn about the depositional landforms. Okay. So first one is outwash plain. See, outwashing means something like if some relief is there or some features are there, they are washed out, they are removed, and as a result a plain area is created. Let's say there is a mountain, glacial mountain, and from here many glaciers will be like doing the erosional activity, they will be coming down the slope. And in these glaciers, when we talk about glacier, generally first thing that appears to our mind is it's a kind of huge ice block. So we think that ice block means only water is present, but apart from water there will be many sediments present in it. There can be dust particles, there can be debris, there can be some organic substances, many things could be present. They get solidify within the water and they may get trapped inside. Now when such glaciers, due to any reasons like gravity or landslide or earthquake or due to melting, due to any of these reasons, let's say it is moving down the slope, then as it is moving down the slope, it will be dragging and creating some erosional landforms. And as the slope is reducing, what happens? The velocity of the ice block is going to reduce, similar to the river we have seen. So the moment it comes to the foot of the mountains, let's say this is the ice block which has come to the foot of the mountains. Now the velocity is going to reduce, and as a result of it, erosional activity will reduce, and now the depositional activity will increase. Why? Because within it there will be many rock particles, dust particles and other things. Now as it has come to the like foot of the mountains, now slowly it is also going to melt, and the melting is going to release the water and also the sediments which are present inside, and as a result those sediments start depositing along the foot of it in the plane in which it is moving. So in this region, like the normal plain regions, when it debounces the mountains, it starts depositing the material in the area and creates a plain kind of region. That plain is what we call it as outwash plain. See, maybe the diagram may not be clear, but if you look at this image, you get the clear picture. See, here we have glacial mountains. Now from there many of the glaciers are coming. Okay, they are like moving. Now down the slope when they move, they will be moving until here there is a snow, but after that it starts melting, and whatever the material that is present, you can see it is being deposited in this entire region. Such a plain area which is created due to deposition of the moraines. Moraines means the sediments which are present inside, is what we call outwash plain. Okay, first let us understand all of them, then we will write. Now there is another feature which happens here, that is along the path of the glacier. Let's say there is a big glacier which has come down to the foot of the mountain into the plain area. So in the outwash plain area, when it is moving, let's say it is moving in this path. Now along the path, as it is moving, the water is going to, like the ice is going to melt and water is going to like follow the slope and go away from there, and whatever the sediments that are present, they are going to be deposited along the path of it. Akash, I'll explain it. Let me complete this, then I'll address your query. So they start depositing here along the path, and as a result of it, as the time progresses, it appears that along the path of the glacier there is a tail created showing the path of it due to depositions of the material which are present inside the glacier. So it appears like a kind of embankment. Somebody has created some sort of embankment. This is due to deposition of whatever the material that was there inside the glacier. Such embankments along the path of the glacier are called esker. You can see it here. Let's say here, this is the place where the glacier started moving, and along the path of it, here you can see there is a deposition of the material. It can happen down the slope or after entering into the outwash plain also. You can see here, this is a path created by the glacier. You can notice it, initially it is wide, it is having more width and breadth, and as the time progresses, as the glacier moves, it is going to become narrower and narrower, and there will be a time where it is going to be completely disappeared. Can you guess what is the reason behind this? Initially the ice block is big and there will be lot of sediments. As it is moving and melting and depositing, so slowly the size of the ice block is going to reduce and completely disappear. As the size is reducing, the amount of sediments present in them is going to be lesser. So as a result, depositions will be less. So that's the reason why, see here almost it is disappearing and here it is very wide. This kind of tail kind of features which appears like embankments are called eskers. It's a kind of a ridge or an embankment. So in the outwash plain, they can also act as a natural paths. We can take the advantage of it and we can construct a road or some connective path, or even we can use it for flood mitigation and other kind of things. Okay, this is esker. Now from our online student, there is a query: how a glacial depositional landform different in its features than fluvial depositional landforms? Don't both of them carry down the sediments? True, but carrying down the sediments in case of river, see, is asking how depositional landforms of river and glaciers are different. Both of them are carried by the same thing. Only thing is, one is in the solid form, another one is in the liquid. Valid question. The reason is why there is a difference. See, in case of water, the load will be segregated. Initially there will be deposition of bigger boulders and rocks and all, then smaller ones, then smaller ones. So that gives a gradation based or graded based depositional features. But in case of glaciers, there is no such a segregation. Wherever, let's say here the melting is happening, let's say this layer is going to be melted here. Now in this layer there can be smaller sediments, there can be bigger boulders, there can be some sort of organic matter or many other things. Now as it melts, all the things are going to be deposited here itself. There is no gradation. Got the idea? Further, the actions are also going to be different. The location is also going to be different. The manner of deposition, see, it may happen, see, if you look at here, you will get it. The deposition may happen in the center of the glacier, or it may happen in the sideways, or it may happen at the bottom. You can see in the center the depositions are happening, sides the deposition happening, or at the end the depositions could happen. So there is no fixed place, but in case of river there is a fixed pattern, like this is how the depositions are going to happen and we are going to get a landforms. Akash, clear? So eskers are done, outwash plain is done. Then the third variety is drumlin. See, same mechanism like moving of the ice block like a esker. The only difference is here the ice block is going to move slowly, and in that process the depositions are going to happen in the confined region, and due to this it is going to give a inverted boat shaped kind of depositional features. Now how the mechanism works here, how it happens, let's say we have a big glacier and it is moving slowly. Initially it starts depositing the material, then slowly the rate of deposition is going to pick up because the melting is going to be picked up. So there will be many depositions, and as it starts like moving, let's say here, now the size of it reduced. Now here there will be less number of sediments deposited, next further less number, next further less number, then finally less number. So as a result of it, it appears that the depositional features of it is going to give a relief which is of a kind of a inverted boat. So this is side view we are looking at. If you look at the top view, this is how it looks, this kind of feature. So such a depositional features are what we call drumlins. So the difference between esker and drumlin is going to be more confined, and in shape it is going to be inverted boat, and whereas esker is more like an embankment, so it is wider at the beginning, and as it is going towards the end it becomes narrower and vanishes, kind of a tile. Then another landform is kettle hole, and from here kettle lakes can also be created. So what is a kettle hole? Let's say there is this glacial mountain, and here outwash plain is created by the glacial activity. Now another glacier is moving from here, and down the slope it has moved and it came here, and the moment it reached, due to see, the outwash plain is not going to be very strong, the materials are going to be very soft, and there will be water like highly saturated. It appears like you can say kichad wala, okay, or it's kind of a semi solid state of the soil because it is highly saturated with the waters given by melting glaciers. So already there is this kind of semi or weak layer is present. Now when it is moving through it, due to the weight of the glacier, it may get trapped. It may get trapped inside and it may create a depression. Like it's kind of like throwing a stone into kind of let's say kichad or some other semi liquid which is highly saturated one. So there when you throw a stone, there a depression will be created and stone will be present. Similarly the glacier is present here, but with the time what happens, the glacier is going to melt and release the water and deposit all the moraines within it. So inside the depression moraines will be deposited, then there will be filling of it with the water. So here you can see this depression was created because at one point of time the glacier got trapped in that area, and with the time whatever the water that was present, it got melted and the depositions got settled here, and later it has become a depression. So such depressions are called kettle holes. Now when the depression is filled with water, we simply call it as kettle lake. Kettle lake. So kettle hole, kettle lake. Again it is a depositional one. In the outwash plain, because of the deposition of the glacier it is happening. Then one more thing is moraines. See, moraine is all the sediments that are present in the glacier, and they can be deposited along the path of it or at the end of it or at the beginning of it or sideways. So depending upon where the depositions are happening, we can have different types of moraines. We can have the central or medial moraines, we can have end moraines which are deposited at the end of the glacial activity, or we can have lateral moraines like sidewise depositions. As the glacier is moving, sidewise depositions can happen. So as a result, we can have these different types. So just to give a summary of it, in this glacial activities, we can have both erosional and depositional features, and mainly where they are found in the mountains with glaciers. Generally, the mountains which have a height of more than 6,000 meters, they are the most ideal ones to have the permafrost. Permafrost means permanent presence of the snow. There the land is covered with the snow and we can have the big ice blocks. In such areas, due to the erosional activity, we can have a corrie. What is a corrie? Corrie is a depression or a hollow basin cut. Then we can have a arete. What is an arete? Steep sided ridge between two corries. Then what is an horn? When back to back aretes meet, they give rise to a pyramidal peak which looks like a horn. That is what we are referring to. Then they can also form a glacial trough. What is a glacial trough? It's a big depression, extended big depression which is cut by the continuous erosional activity of the glaciers. Then we can also have a hanging valley. What is an hanging valley? It's a small depression cut by the glaciers or small rivulets which are not strong enough to cut it deep to bring it to this level. That's why it appears a valley is hanging at a height. That's why we call it as hanging valley. Then similarly, the depositional activity also lead to various depositions. See here you can see there is a Kettle Lake, Kettle Hole and Kettle Lake. There is a drumlin. See, series of drumlins are formed here. There can be an esker, or there can be outwash plain. Okay, there can be moraines, various types of moraines. So on the basis of it, we can have outwash plain, or we can have an esker or drumlin or kettle hole. When it is filled, it can also lead to formation of Kettle Lake, and finally moraines. Now within those moraines also there can be various types of the moraines depending upon the location. Like we can have lateral moraines, we can have medial moraines or central moraines, or we can have end moraines. And moraine is not segregated, it is a mixture of all kinds of material. There can be big rocks, there can be valuable minerals, there can be small sediments, there can be clay, there can be organic matter and many more. Okay. So now let us write glacial landforms of depositional nature. Okay. So please put the first subheading, that is outwash plain. Outwash plain. When the glaciers reach their lowest point and melt, lowest point and melt, they leave behind stratified deposition of rock debris, clay, sand, gravel, etc. Such layered surface is called outwash plain or till, T-I-L-L, till plain. Okay. Next, second one, esker. Please write, it is winding ridge of, it is winding ridge of unassorted depositions of glacial material along the path of glacier, in a till plane. Till plane, or you can write outwash plane, same. Stop. They resemble, continue on the same, they resemble features of an embankment and are often used for making roads. Next, drumlin. Third one, drumlin. It is inverted boat shaped deposition caused by glacial melting and deposition. Diagrams all together we will draw in one case and we will highlight them. Okay. Then next, kettle hole. Please write, these are formed when the deposited material in a till plane gets depressed locally and forms a basin. So when such basins, continue in the same, when such basins are filled by water, it leads to formation of kettle lakes. Stop. Next, last one, moraines. Please write, it is a general term used for the we call it as load, you can say glacial load, the material which is present inside the glaciers. General term used for the glacial material such as rock fragments, gravel, sand, clay, etc. Depending upon the position of deposition they can be classified into first category lateral moraine, lateral means on the sides of the glacier if the deposition happens, lateral moraines. Then the second one is medial, so this is at the center of the glacier. Then end moraines at the bottom or end of glacier. Okay. Now all of them we will present it in diagrammatically. Since we have already done for erosional, let us go for only depositional. See, for this let us take there is mountains, glacial mountains, and from there there is a formation of outwash plain. If you want, you can give 3 dimensionality to it. On that side we can't see. Okay. So from here when the glaciers are moving, so in one case it can lead to, like this entire thing is what we call it as outwash plain. Now within this outwash plain we can have an esker. Either it can be like this or it can be spread, like the depositions could be spread as the water finally spreads out. So this is what we call it as esker. Now the similar kind of it we can have in a shape of inverted boat or a kind of tear drop. So this is what we call it as drumlin. Okay. Then kettle holes or lakes. Okay. What else we have seen? There is moraines are there anyway, moraines we can show it anywhere. What is the another one? Outwash plain is all done, esker is done, drumlin is done, kettle. This the last one is the moraines, different kinds of moraines. Let us say there can be moraines here, or there can be along this, there can be depositions. Okay. Like these are depositions, like let us say there is a deposition like this as shown in the diagram. Okay. Or it can be like this. So all of it they can be termed as moraines. Done. So please write it, no issue. These are all some of the glacial landforms. Which one? Here, this one. That is also moraine. Just we are trying to show lateral moraine there. So it can be end moraine. You can write medial moraine also, like It can be depending upon the position. Just to give an idea, we have drawn that. Okay, done. Now, three landforms we have covered, three types. Volcanic done, landforms created by river, we call them as fluvial landforms done. Now glacial done. Now let us look another type of landform created by the action of the wind. Okay, and particularly the wind is a major force of erosion and deposition in arid locations. See, arid locations, the rainfall is not so high and water availability is not there. There is a scarcity of water. In such a drier conditions, wind, because of the pressure differentials, say in arid locations temperature is high compared to the nearby locations. So in the arid locations there will be low pressure, and in the surrounding areas there will be high pressure. So from all the surrounding areas there will be high velocity winds moving into the deserts or arid locations. As a result, they can do some erosion, they can do some deposition. So we will try to look at what are the various landforms created by the wind, particularly in arid and semi-arid locations. Okay, so please put in a fresh page, arid landforms. In arid locations, please write, in arid regions, arid means you can say desertic or semi-desertic, okay, arid regions, the rainfall is scanty, water is scarce. Water is scarce. In these regions, wind is the main agent of weathering, transportation, erosion and deposition. So as a result, it can form various erosional landforms and depositional landforms. Various erosional and depositional landforms. Done. So now let us see what are the various erosional ones first, then we will see the depositional ones. So please put the subheading, that is erosional landforms. See, earlier while discussing the erosion, I have talked about three types of erosions: sheet erosion, splash erosion and gully or rill erosion. Now you can see gullies and rills. Rills are small narrow channels cut by the running water. See, particularly in the arid or semi-arid locations, rainfall is scanty, the soil is you can say highly loosely bound, okay, it is very dry, it is not at all compact. There by chance, even if there is a small rainfall, it can result in like lot of surface runoff, resulting in lot of erosion. So that can create rills. Rills are, you can look at it, these channels like narrow channels due to erosion are called rill. Now if it becomes bigger, wider and bigger, we simply call it as a gully. Got it? both of them can be frequently seen in the arid locations. Now you might ask, sir, how they are being created? You said there is scanty rainfall. Yes, scanty rainfall is there, but rainfall happens at times. So whenever it happens, since the soil is very loose, it will lead to massive erosion, creating such depressions. So this is one feature. Then another is ravine. See, this is a kind of narrower than canyon kind of valley, which is cut by small river streams in the arid locations. So in arid locations also we can have small river streams coming from the natural springs, and they are going to cut the region, erode the region, and make very deep narrow cuts. So you can say it's a gorge, kind of a gorge, but the difference between gorge and ravine and the canyon is gorge is narrow, V-shaped and limited to a size, it is not extended, and your canyon is wider, longer, it might go some kilometers also. For example, you look Grand Canyon of Australia, such a big one. Okay. Then intermediary to this, if we have narrow, very narrow one, but extending for a longer distances, without broadening, if it is extending for a longer distances, we can call it as a ravine. So here this is a ravine, some people are going, and you can see here there is a small rivulet, stream flowing through it. Here you can see the water. Okay, such things are called ravines. Then first listen all of them, then we will come to notes. Then one more thing is bad land topography. What is it? See, it's a overall topography of a desertic area or semi-arid area where rainfall is less and wind erosion and deposition is very high. As a result, all the loose material will be taken by the wind to another location, and resistant material of undulating shapes, no regular shapes, will be left behind. So maybe there might be a small mountain, or there might be a mound of hard substances like resistant rock, or maybe very strongly compacted soil. So such a topography is what we call it as bad land, because it is not useful for any productive activity. You cannot do agriculture, you cannot set up an industry here, you cannot have transportation through it. So such a topography is called bad land topography. Now within it we can have various other things. For example, bolsons. What are bolsons? Like, see, in the bad land topography you can have different mountain kind of peaks. Let's say this is the entire arid location, and here you may have some mountain or some sort of mounds, not exactly mountains but mounds which appear like mountains. Okay, these are formed due to erosional activity. All the erosion, wind has taken all the loose particles, and whatever resistant, that stayed back. Generally that is the core of the material. So it stayed, and here there is such a thing. Now between these two, like intermontane basin, there can be a basin kind of region. Such basin regions are known as bolsons. Now within these there can be different other landforms created between these intermontane plains. What are they? See, it can be a piedmont, or it can be a bazada, or it can be a playa. See, let us see what are they. Like, what is a piedmont, what is a playa, what is a bazada, what is a mesa, all these things. Now if you look at it, here we can also have the plateaus, but plateaus we will cover it separately. See, we can have a plateau, or we can have, see, at the see, these are some sort of elevated portions. At the feet of it we can have alluvial fans, if the streams are bringing some water and depositing there. Even rarely when the rainfall happens, then also streams will come and may deposit, and we can have a alluvial fan similar to your fluvial landform. Or you can have this entire plain area between two mountainous regions, is what we call it as here just now we have seen, that is what we call it as the bolsons. So there can be bolsons. Within these bolsons we can have a playa. What is playa? Let's say in this plain area, if the rainfall happens, due to that slope whatever the rain that is accumulated here and here, that has to ultimately come and settle here, and it might form a temporary lake for a small period of time. A temporary lake can be created. It's accumulation of water. Now one thing is, such waters will have salt content, but in the arid locations the rate of evaporation will be much higher than rate of precipitation. So the water is going to evaporate, but the salts present in that water will stay back. Okay, so initially less amount of salts, but when this process happens for a repeated number of times, slowly the salt content in this region is going to increase and it appears like as if a kind of a salt laid a plain has been created there. You can see it here, this kind of salt pan has been created. You can see if you go to a drier locations, or even in the normal cases, if you see there is a evaporation of water, accumulated water in the recent times, you can see small white patches. That's because of accumulation of salts. Now if it happens in a huge number, that can even give you a thick layer of salts. Okay, such ones are called playas or salt pans. Okay, then Piedmont. Piedmont means at the feet of the mountain, whatever the depositions that happen, they are called the Piedmonts. The slopes, so some of them can be alluvial fans as well. If they are in this shape, we will call them as alluvial fans. Otherwise, if they are simply the mound shaped, we call it as Piedmonts. So these are depositions which happen at the feet of the mountain. Okay, then Bazada. So simple sense, Bazada is a kind of plain in the arid location. But however, this is not due to the activity of river or running water or anything. It's due to activity of the wind. See, when wind is also going to pick up some material, small dust particles and all. Let's say wind strength reduces, then those dust particles will be settled, and that can create a formation of a plain. So this is a depositional one, not a land erosional. We will write it in depositional, but since it is related to bolsons and other things, that's why I am keeping it here. So such a depositional plain which is created in the arid location by the action of wind is called Bazada. Simple. So these are all some of the landforms. Apart from that, there are few more which are more peculiar and more interesting. That is, one of them is mushroom rock. Mushroom rock, or sometimes it is also called pedestal rock. See, by looking at the shape of the rock, you can tell why it is called mushroom rock. Why? The shape is appearing, it is resembling a mushroom. Now let's see the mechanism, how it is formed, why such peculiar things are created in the arid locations. Let's say there is a big rock in the arid location. Now in the arid location, it will be subjected to erosion and deposition due to the action of the wind. So wind is going to blow, let's say in this direction wind is going to blow, and here there are lot of dust particles in the arid location. Now when the wind is blowing, is it going to pick up the dust particles or not? Definitely. Now out of that, there can be different sized dust particles. Let's say there are big sized ones, there are small sized one. Now between this big and small sized one, which one will be picked up to a greater height by the wind? Smaller one, because they are lighter, and the more coarse one will not be picked up, rather they will be dragged by the wind. So as a result of it, in this movement of the wind, smaller particles will be at a greater height and slightly bigger sand and other soil particles will be at the bottom. True. Now it is coming and hitting this rock. Erosion could happen. Of course, it is not immediate one, it would take some thousands and millions of years. Okay, so erosion, every time when this happens, erosion will happen. However, if you look at it, the impact will be more at the bottom or at the top? Bottom, because there are big sized particles. So as a result, in the bottom, the erosion is going to intensify compared to the top. Okay, the bottom is going to be eroded further and this entire material will be removed with the time. Now just imagine the same mechanism from this side, from the back side, from the front side, in all the directions, like from here, from the back side, from the front side, in all the directions same mechanism happens. Let us say from here it is happening and there is a differential erosion and this eroded this entire material. Now what we got? The shape of the rock is mushroom. So the main reason is differential erosion done by wind at the feet and at the top of the rock. So now you may ask, sir, why this portion is not completely eroded, why this is present? Because it is core of the rock which is resistant to that wind action. That's the reason why it is able to withstand and not erode. Okay, so as a result of it we start getting rocks which appear like a mushroom. This is also erosional feature. Okay, then comes inselbergs. See, inselbergs are huge rocks, isolated hills or rocks which are found in the arid locations. They are mainly created due to erosional activity. So when erosion happens, whatever the resistant core material is there, that will fall, like that will appear like a big mountain or a big rock which is lying in the arid location. Such a thing is called inselberg. See here in the image, not this one, this is some hut, this one, this is the inselberg, big rock is called a inselberg. So this is another erosional feature. Then apart from that there are few more erosional features. One of them is yardangs. Generally it is seen in the coastal areas, it is seen in the arid locations which are adjacent to the normal locations. There wind, due to differential pressure, wind is going to blow at a high velocity. So let us say when wind is moving in this direction and there is a series of rocks, okay, or there is a big rock or a series of rocks are there. On these rocks there will be differential erosion and at the bottom it will erode more compared to the top. As a result it starts giving the rocks which are aligned but eroded in the shape of the in the direction of the wind. See, the shape of yardangs, a series of eroded rocks, can give us what is the persistent direction of the wind. You can see here this portion, you can look at it, it is been eroded more compared to this portion and this portion is not at all eroded. So that means wind has been continuously blowing in this direction. That is the reason why every rock in this series is showing the same shape. So such ones are called yardangs. Okay. Then wind bridge and wind window, how they are created? Let us say this is also called wind arch. Okay. For example, in Tirupati there is a temple, Tirumala temple. If you go, there is a rock bridge called Silatornam that is created by the wind action. Okay, it appears like a natural arch, natural bridge. So how it is created? See, let us say this is a big rock and inside the rock there can be weak joints, weak spots. Let us say there is one such weak spot. Now when it is being impacted by the wind's action, wind is constantly going to erode it and slowly this is going to erode and remove the material, and when the erosion happens for many number of years, so it may be able to take out the material which is present here and create a hollow hole like this. Now such a hole generally is what we call it as wind window, because it appears like a window, like you are this side of the rock, you can see the other side of it, wind window. Now let us say when further erosion happens further and further and it continues to erode more and more material, okay, further and further erosion and removing, this entire thing has been removed, only this thing is standing. Now the shaded one is standing the hollow one is removed. So this can happen, which can give rise to arch, kind of arch. Now let's say it extended and further erosion happens between two rocks, okay, that can give rise to a kind of a bridge between two rocks. Actually, if you look at it, you can see here there is a, it appears like there is a bridge connecting them, but in reality this is, at one point of time this entire thing used to be one rock, and slowly it created a window somewhere here, and the window started like becoming bigger and bigger and bigger and removed all this material, left only that bridge portion. Otherwise this would have been like this is supposed to be the shape of that rock. So this is what we call it as wind bridge. Okay. So these are all some more landforms, erosional landforms. So first let us write about the erosional landforms, then we will come to depositional ones. Okay. Depositional ones are less in number, but erosional ones are very high in number. Okay. So please write erosional landforms. Those who are in the live, clear, right, till here? Okay, first rill, R-I-L-L, rill. It is a narrow and shallow channel narrow and shallow channel cut into soil by erosive action of flowing water. Erosive action of flowing water. If you want to make, you can make diagram. Just for 3-dimensionality I have given this. Here you can draw. You can draw in any random shape, you do not have to follow me. Water can flow in any direction, as a result it can create such narrow and shallow channels. Second, gully. Please write. A gully is landform created by running water which resembles a large ditch, D-I-T-C-H, ditch or small valley extending in depth and width. Depth and width. Please write. Next, ravine, R-A-V-I-N-E, ravine. It is a narrow extended valley, narrow extended valley cut by small river streams, cut by small river streams. See, compared to gully it will be bigger, compared to canyon it will be smaller, and compared to gorge it will be longer. Okay, same V shaped and depression will be there, but length will be slightly bigger. Okay, so this is what is. See, gully, if you want you can draw like it's a kind of bigger crack. Same, in the same one you can present like this entire thing, this entire one can be called as a gully. You can name it like make a small change to it and you can name it as ravine, and this we can make it small because we do not want to give the impression that a rill is such a bigger one. Rills are smaller ones. Okay, so this will take care of all three of them. Simple. Let us say this is rill, this is gully, and this is ravine. Done. Now we can write another one, badland topography. Please write, it is an extensively eroded region in arid or semi-arid locations characterized by steep slopes, minimal vegetation, lack of regolith. Regolith means rocks, different rocks, etc. No need for drawing the diagram because in the next one we will show most of them. Then please write next one, bolsons. The intermontane means between mountains, two mountains. Okay, intermontane basins in dry regions intermontane basins in dry regions are known as bolsons. Next, playas. When small streams flow into bolsons small streams flow into bolsons due to accumulation of water, due to accumulation of water, temporary lakes are created. These are called playas. Next, when the water evaporates, the salt covered playas, you know why the salt is going to be deposited there, okay, all the accumulated salts are going to be left, only water is going to evaporate. Salt covered playas are called salt pans or salinas. Salt pans or salinas. Next, pediment. Pediment is right. It is a rock cut surface at the foot of mountains. At the foot of mountains. Then bazada. Okay, let's not write bazada here, we will write it in the deposition. Rather than bazada, you write mesa. M-E-S-A, mesa. Please write. It is a portion of plateau which is isolated from main plateau. In some of the arid locations there can be a isolated plateau which is separated from the main plateau, that is called mesa. Now when such mesa is subjected to erosion, let us say there is this area, arid area, and here there is, okay, this is plateau, and out of which a small portion is isolated from it. Okay, there is a gap, I should show it as gap. Let us say this is a plateau in this region, okay, and there is a small another plateau which is isolated and playing here, and this is called mesa. Now let us say when mesa is subjected to further erosion due to action of the wind, it may sometimes reduce in size and it may become a kind of tower, okay, narrower one, a steep kind of a pillar or a tower. So such tower is called butte. Okay, butte. Okay, please write. Next one, butte. B-U-T-T-E, butte. It is an isolated tower formed due to erosion of a plateau. So it indicates that at some point of time there was a plateau and it's a remnant of it, and as erosion happened, it was reduced to this butte. Okay. So these are some. Then one more thing we'll write, mushroom rock. Let's write mushroom rock. It is a mushroom shaped rock, mushroom shaped rock created by the differential erosion of wind at the bottom and top of a rock in arid locations. Arid locations. ठीक है. We are to write the diagrams. So for this you can draw, but earlier ones we have to draw, right? So let's draw the diagram, some of them, and whatever that we have covered we will present it in one place, then we will go and write about the mushroom. Okay. See the other ones, let's say this is the entire arid location. And let us say there is a mountain, at the feet of the mountain there is a rock cut deposition which we can call it as pediment. Okay. Now we can have a plateau. So I am going to indicate the plateau like this, because I cannot give the three dimensionality, that is why I am indicating like this. The plateau can be there and a portion can be isolated from here, and we can have a mesa, and when it is further let us say eroded, and we have a isolated pillar kind of thing which we call it as butte. Sometimes we can also have the alluvial fans, okay, which are depositions in the conical shape from the plateau, and let us say here there is a deposition of temporary lake, that is what we call it as lias, and the plain area, this is what we call it as bazada, the entire plain area. So sometimes when it gets like completely evaporated, let us say there is a deposition of the salt, such a thing I can call it as salt pan or salina. So for this to happen, first the water has to be evaporated, salina. We can also have the water bodies within it, they are called oases. We will cover them. These are some of the peculiar areas where there is groundwater reaching up to the surface, and as a result even in the arid conditions there is a perennial availability of the water. Such things are called oases. Okay, next mushroom rock we can draw. You can have various layers. If you want to show, you can show it, otherwise that is fine. Mushroom rock. Next, Inselberg. Please put this subheading, Inselberg. It is a large isolated hill or rock that rises abruptly from a gently sloped surrounding plain, gently sloped surrounding plain area. So in the same you can also put one big mountain like kind of rock, and you can call it as Inselberg. Then now we can look at the depositional landforms. Oh, Yardangs are left, right? Okay, please write Yardangs, Jugen. So these are all some more. So let's write about Yardangs. These are ridges of rocks, formed by action of wind, parallel to I will explain, Akash, parallel to the prevailing wind direction. The question is, what is the difference between butte and the Inselberg? Inselberg is any big stone or a mountain or any structure. It can be of random shapes. The butte will be a portion of the plateau which got eroded massively, and it appears like a kind of a tower. Okay. So there is a difference even in the material also. See, plateau, a butte can be of simple soil and rock, and Inselberg can be a very big rock. Okay. And shape and size Inselberg is much bigger than the butte. Okay. These are all some of the differences. Now another one, please write wind, window and bridge. Wind, window and bridge. Please write, when a hole is created in a rock due to erosional activity, it is called wind window. Next, when this hole further widens to form an arch like feature, it is called wind bridge. It's called wind bridge. Done. So these are all some of the erosional ones. Now we can look at the depositional ones. Okay, so please put the next subheading, that is depositional landforms. Here the landforms are less in number, so we can parallelly discuss and write about them. Okay, the first one, please put ripple marks. In movies you might have seen in the desertic areas this kind of marks, okay, which are series of ripples, a kind of ripples created in the sand. These are the ones which we call it as ripple marks. These are due to the deposition, like as the wind is picking up some particles, it is going to deposit in a random manner, creating the ripple marks. But however, the direction of it and the pattern of it can give a hint about the wind direction, but they are highly liable to change. See, suppose now they have created, they are being created like this, indicating one direction. Now tomorrow if the wind is coming from here, they may be deposited and created like this. So they are highly dynamic and they generally align with the wind direction, okay. So please write ripple marks. These are depositional features on small scale. Small scale as the wind transports hard particles on an uneven surface, See, this kind of thing we can also see it in ground, let us say bare ground where the wind is flowing. Sometimes we can notice such kind of ripple marks in the grounds as well, normal grounds or bare grounds where the grass is not there and soil is high. So this is one variety. Second is sand dune. Please write, these are huge mounds of sand deposited by wind in deserts They can be of various types based on their shapes. See, for example, there can be transverse dunes. See, they are more like crust and trough kind of things, okay. So they will be deposited like this. Here deposition is there, wind deposition, you can see it here. Or they can be longitudinal, where along the direction of the wind they will be deposited like this. See, the difference between ripple mark and this is the quantity of the wind, the quantity of the sand which is deposited. Here very less amount, liable to change, but here huge amounts of sand will be deposited and they are more like mounds which are found, okay, this kind of thing. Then there is a special variety which is called barkan, and that is crescent moon shaped. See, for example, wind is blowing in this direction and it is going to pick up these sediments and it starts depositing slowly here, and in the center there will be more deposition and in the edges there will be less deposition. As a result, it will start depositing in a crescent moon, okay. So finally they will end up in this shape, all these depositions. Such crescent shaped dunes are called barkans. Then within them there can be another variety, that is star shaped. Let us say if the wind is moving in this direction, it has created a barkan in this direction, and tomorrow if the wind changes and moves here, we can have another barkan here, and if it moves here, so all these directions they are going to create different types of barkans connected, like these are all connected. So as a result, it may so happen that these overlapping ones will give an appearance of a star, like it appears like this back to back connected ones. So such ones are called star shaped or star dunes. Okay? So please write. First, longitudinal dunes. See, these are generally parallel to wind direction. Next, transverse dunes. These are perpendicular to wind direction. Then the third variety is Barkans. These are crescent shaped. Here I have written, you can take crescent shaped, crescent moon shaped dunes. Then last, that is star shaped or star dune. As the name suggests, they are like star shaped dunes. Done. These are all subcategorizations. Then please write loasis. Loas. These are depositions of fine silt in the adjacent regions of deserts. They are highly fertile for agriculture. Only the limitation is water. If the water is available, they can be cultivated very intensively. Okay, highly fertile for agriculture. So these are all different depositional landforms. Then a special category, that is a peculiar one, which cannot be put it in either depositional or in the you can say erosional, that is oasis. See, what are oasis? These are some depressions with water facility, and it is a unique landform here. Why this happens? Where groundwater in some cases in deserts also reaches to the surface naturally. So as a result, there can be water availability on the surface of the desertic areas. Such ones are called oasis. Okay, please write, put subheading oasis and write, it is an unique water landform surrounded by desert, so it has a water source underground, and supports vegetation and animal life. Okay, done. So these are all arid landforms, or landforms created by the action of wind, particularly in the desertic areas. Yes.
Here the only source is through the deposition from the underground or any other source.
Which one? Where?
Those.
Oasis. See, it's mainly from the ground, underground groundwater. Wherever the groundwater is available to the surface, there oasis can happen. No other source, like rainfall can happen. You might be thinking of rainfall. Rainfall might happen and that might give some water, but it is not going to be permanent. It will create a temporary effect. Okay, the permanent water availability is due to the underground or surface, groundwater reaching to the surface, where water table is highly at the surface. Okay, so this is all about the landforms created by wind in the arid locations. Then we can talk about the karst topography, karst landforms, but I have been given one small request that I have been told that you have exam tomorrow, the weekly test or class test, and it is a subjective one or objective one. What type of test? Both. How many MCQs are there? 20, 25, okay, 25 means 50 marks. Then how many subjective ones will be there? Then why you are saying 10 questions? Okay, that is completely mains oriented, that's why. Okay, anyway, so let's assume there are 3 questions for answer writing, like mains questions are there, and there are MCQs. Now I will give some strategy or some approach to the prelims exam and mains exam, not particularly for any weekly exam or particularly for this pattern. Generally in MCQs, why many of the aspirants make some mistakes is, number one, negligence in reading the question thoroughly. The moment we see something related to what we know, we get overexcited, we get happy, and we think that this question I know, and immediately we start going for answering. So always remember, before answering, understanding is more important. So try to understand the question, what the question is asking. So read it thoroughly, you will have enough time. Say in the prelims examination, 2 hours time is there for writing 100 MCQs. So there is enough time for reading each and every statement and each and every aspect of the question. Sometimes in the question they say incorrect rather than correct. They say, they don't even highlight it, or they say not instead of what you think, like which is the feature, which is not a feature, or they might add some things, or they might slowly make some small changes. Like the other day we have put batholiths or I think sedimentary rocks or something, such things. So if you overlook small details, you will make a mistake. So give attention to the detail and read the question thoroughly, each and every section of it. So this is first thing. Second thing is, sometimes you might face questions which are not known to you, you don't know. So in such questions, like how to handle the unconventional questions or questions which are not covered by us. It happens in any subject, it happens, particularly in civil services. As it is evolving, there is a high chance that there can be some questions out of the box. Now when you see such question, don't panic, read it thoroughly. So this is where the common sense and reasoning and elimination is going to help. In such questions, based on the information or the statements given, try applying your common sense on the basis of it, whether it is going to be true or not, and try to see the synergy between the statements. Let's say 2 statements are there, both of them are contrasting in nature. If both of them are contrasting, both cannot be true. So on that basis, you can remove 2 options, like both 1 and 2 can be removed and neither 1 and 2 can be removed. Now out of it, there is a 50-50 chance. So that will improve your chance of getting to the right one by 50%. So you can reason with the statements. Let's say the statement you have read and it has given some information, on the basis of it you apply it and reason with it, whether this statement can be right or can be wrong. You try to find some counter examples. If counter is there, with that counter you can say clearly it is wrong. For supporting there can be different other examples, but countering, one example is more than enough. On the basis of it you can say this is wrong. Then comes elimination. Like in that process, even try to see, there might be 4 statements, let's say, out of which you know only 2 statements, remaining two statements you don't know, or you heard about it, you read about it, but you are not able to recall or remember. In such a case, first go with the statements you know for sure, and on the basis of it look at the options if anything can be eliminated or not. Sometimes even with one statement knowledge also you can come to the right answer, remaining 3 you don't even need to know. So if such possibility is there, you go with that. But nowadays the UPSC is making questions where instead of what, they are asking how many numbers they are asking, where you need absolute knowledge. In such a cases you have to have a absolute knowledge, first to do the eliminations and come to the logic, and on the basis of it see whether you can take 50-50 risk or calculated risk can be taken or not. And you should take only calculated risk when you are on the borderline. Let us say if it is for 50 marks, you can consider it as 50% as the borderline. If you get 50%, more than 50%, you are through in any prelims. You look at the previous year cutoffs, they are not going beyond 80, 85 or so. We are even taking 100 as the par in our practice exams. Let us say if the test is for 100 marks, you try to get just in the vicinity of 50 marks. If it is for 200 marks, you try to get it within the range of 100 marks. Plus or minus 5% margin is okay, no issue. Okay? So in this range, and when you are in that range, just in the border, then you take the calculated risk, that too with the logical reasoning. Don't like Bhagwan ka naam pe mat karo. Okay? You take the calculated risk. That can like if it goes in your favor, you will be above that cutoff. Okay? Or if you are like already, let us say out of 100 you are confident that you will only get 10 marks, then sab karo, baro, sorry. Okay, anyway you are not into the thing then. But mostly with the candidates who put efforts, it won't happen. It happens for those who come to the exam without any preparation, just dekhte hai exam kaise. Let's have a look at it. And this time I will have an experience and next time I will prepare such kind of candidates. Okay, so it won't be applicable for you, but this is what is applicable for you. Okay, try to get into that range. And one more thing is trying to get to too many marks. Like I have seen people, if 100 questions are there in the exam, they will attempt all 100 and try to get 200 out of 200. Don't do this. In that, see, it is general that at least there will be 10 to 15 questions which nobody knows exactly what is the right answer. Maybe by luck if it gets, that's fine, otherwise no. There will be such questions in the real exam. And we don't have to get 200 out of 200. Even if you get 200 out of 200, or even you get just above the cutoff, 0.1 mark above the cutoff, both of you are equal. The person will be getting the chance to write mains, you will also be getting the chance to write the mains. Okay, so for getting that higher score, either peer pressure ke wajah se or to get better rank among your friends or so, don't burn your hands attempting too many which you don't know. See, in the exam it appears like the questions are very easy and you can guess and you will get, your guess is going to be right, but when you check the key, that is when you will feel I should have not done that. Okay, try to restrict yourself and control that nerve and attempt what is needed. Even if you are not 100% sure with respect to a question, you know 50-50, but you are already above the cutoff. In such a case, don't attempt it. You are already above the cutoff. Why to attempt it? And it means 50% negative chance is also there. No. Why to take that? Because when you make one question wrong, it's not 2 marks that you will be losing. It's minus 2.67 marks. For every wrong attempt, there is minus 0.67 marks. So restrict yourself in like over attempting. Calculate it. And this also depends upon the difficulty of the paper. Sometimes the difficult paper is there, then attempting very less is also fine. Okay, I will share my experience. I have, like, every time I was able to clear the prelims. Only this is the strategy I used to follow. And in one attempt, I don't remember, I think 2017 or so, paper was very tough, very tough, and like not tougher than 2023. 2023 is very tough. Okay, and I attempted, generally my attempt would be in the range of 80 to 85, because I get an accuracy. See, out of the first reading, generally I attempt 40 questions or so. Here my accuracy is almost 90% in various subjects. So that means at max out of 40, 36 questions will be right, 4 will be wrong. Or even if I take worst case, it will be 35 right. So if I take 2 negative, so I will be having a net of 33 marks, 33 into 2, 66 marks. Now I need 30 more marks to be in the safe range, right? Then in the second reading, this is what I would do in the first reading. I'll be going with, you will be having enough amount of time for multiple readings. So what I am not sure, what I can't recall at that time, I keep it later. I round it and put it as later, I will come back, okay. In the second reading, now all those questions which I know, but I am not able to recall it, or I might have forgotten, I need some reasoning, all those things, I keep it for second reading. Or the ones which I was able to like come back and eliminate roughly about, let's say 50-50%, at least 2 options I could eliminate with the knowledge that I have. So such questions. So here I will be attempting close to 30 or in most cases 35 questions, and here my accuracy goes only to 60%. 60% is the accuracy. I am very realistic, this is the 60% is the accuracy. Like almost 14 questions are going to be wrong here and 21 right. And out of it, if I take the net, 14 means you can take out 5. I am taking one extra, minus 5. So you will have a net of 16 questions. 16 into 2 means 32. Now I have come in the range of 98. Okay. So close to 100. I may need 5 or 6 more marks if the paper is easy, if the cutoff is going to go high. That is when I would go for the third reading. And here at max I touch only 10 questions, not more. At max bol raha hu. 5 to 10, 5 is the ideal range, so that I can come around at 80 or 82 attempt. At max I may go for 10 marks, 10 questions. See, out of which my accuracy is below 50% or in rarely 50%. Like below 50%, even if I take 40% is my accuracy, so there will be, like if I attempt let's say 10 questions, 4 questions will be right, 6 wrong. 6 wrongs means I have to take minus 2. For every 3 questions wrong, 1 question goes, 1/3 na. So it is only giving me 2. So into 2, 4, I will be above 100 plus. This is how I would. And here why my accuracy is only 40%, because here I will be taking the complete calculated risk and in some cases wild guess. Bhagwan ka haath mein, that wild guess. But wild guess once I restrict it to only 2 or 3 questions, not more. 2% or 3%, not more than that, 100 questions. So this way I was able to get to it. Now this is the strategy I have been following, and 2017 paper was really tough. Okay, 16 was very easy, where I scored around 148.67 in GS. Okay, and CSAT around 164 or something. That was very easy, and even that year cutoff was also gone for 116 or something in GS. Then 17 onwards it was falling, and one year I don't remember the year exactly, where the cutoff has gone up to I think 77 marks for general category. 77 marks. Okay. And that year I remember I attempted only 65 questions. I was dead afraid. Like attempt is very less, and even if I wanted to attempt, I know it is going to be wrong because I have no knowledge of it. And questions are very tough. History questions were like, dekhte hi aankhein bahar aa raha tha. They were very completely out of the context. Aise questions are there, very factual. All of a sudden there was a pattern change. Now they are asking how many are correct. Earlier we were highly relying on elimination and other things. Elimination had been eliminated. So this was the time I attempted only 65. But still I was able to make it because my negatives were very less, and here I made only 13 wrong. 13 wrong. So out of it 52 got right, and you take 4 the 8.67 marks goes away. So it was in the range of close to 90s, and the cutoff is below 80, able to make it. So don't worry, even sometimes if the attempt is less, our goal is to clear the prelims, we have to be above cutoff. And many people afraid that I have attempted very less and there will be negatives, so I should attempt more, and they attempt more and they get more negatives, and as a result they miss the chance. So analyze your strengths, what are your strengths, and accordingly while practicing this test you see in so and so subject what is your accuracy. So there are multiple subjects where my accuracy is highly good. Geography is one, polity is another one, environment is another one. In 3 my accuracy is always above 90%. If there are 20 questions, definitely I will make 18 questions right, unless it is completely extreme one. So such high accuracy is there. Remaining subjects, like for example history is one of the subjects which I touch very less. Earlier I was very much fond of it, but later what happened is they diversified the sources, they started asking from different corners and all, which I felt like returns are very less, so I have to put minimum efforts on it, but I have to put efforts. So let's say even if my accuracy is 50% or my attempt is 50% with good accuracy, that's fine. 20 questions are coming, I am attempting only 10, I am leaving remaining 10 I don't know, and out of this 10 at least 6 are getting right. I am falling in my second category and I can make it. So rest of the other things like current affairs, science and tech, and economy is also good. I have a good thing with respect to conceptual clarities, but accuracy slightly less because it is mixing up with current and other applications and other things, maybe sometimes it goes less. So that's how I have made my strategy. Now look at your position and you see what is your strength. Depending upon your strength, now in the practice exams you replicate it. See, we need to study all the subjects, but it is not necessary that we are good in all subjects. Some subjects may be weak, some subjects may be very strong. Okay, so accordingly you manage it. Don't leave any subject. Leaving any subject is very bad. Don't leave any subject, you have to study all the subjects. In some subjects which you feel that even after putting efforts my output is going to be less, there you can compromise slightly, little bit, and emphasize on the other ones, revise it multiple times and make it a strong thing. So this is only for prelims, not for mains. Mains you have to cover everything according to the weightage. Okay, you cannot leave anything in the mains. Prelims you can leave. Okay, so this is for prelims. Now coming to the mains, in answer writing, I have seen a few answers of yours. They are very good. They are according to the demand of it. It's good. Have I ever given the tips with respect to answer writing so far? Given, already given. What you have to do. First, always understand the demand of the question. You write answer according to the demand of the question. Don't write what you know. Write what is being asked. You may know so many things. Restrict yourself and write only what is being asked. Don't keep on elaborating and writing what you know. That will take lot of time, lot of space, and you will be falling short of the space, because in mains questions are already pre-printed. Okay, and as a result of it, if you misuse that space for what is not being asked, then you will be falling short of the space for what is being asked. And if you miss that demand, then you may not get the good marks, even though you have written highly relevant and connected information. That's not of use. Okay, so first thing is understand the demand in answer writing. Second thing is structure. Structurize your answer. Like there will be 3 components: introduction, body and conclusion. So when you read the question in mind with the practice, you can structurize what you are going to write it in the introduction and the body portion according to the demand, and conclusion how you positively conclude it. So structurize it. Initially you practice it on paper. You read a question, you take a rough paper and practice it, and with the time, like if you write 10-20 questions like that, then you don't have to practice it structuring, you can directly go and write it. Okay, structuring. Then the third is content. this is the very important thing. Content is the king in any question. If your content is good, you will get good marks. Okay, if the content is bad and if you start filling the page, even if you write to 10 pages of answer information, you will get 1 or 0.5 marks. Okay, so content has to be like highly relevant to it, and in this content also there is a static content and there is a dynamic content. Static, direct from the bookish sources, whatever the reference sources that you are taking, definition based ones and all. Dynamic is related to current affairs and the data that you use or references that you give. Okay, all these things related to the current happenings or examples that you are going to provide. See, for some question, let's say the tsunami question is there. I have checked some of your answers. Everybody write the same definition of tsunami. Is there any other definition? No, it's a static portion. So definition will be same whether you write it or me write it or somebody else write it. But with respect to the examples, you can give different examples, I can give different examples, I can give other like contemporary things. So this is where we can make our answer unique, not boring to the examiner. So dynamic content. Then the fourth aspect of it is presentation. Present your answer in such a manner that it is easier for the examiner. If the examiner has to put efforts in evaluating your paper, then there will be effect on your marks. You may lose some marks. Okay, so it has to be presentation. Then the presentation can also, you can make diversity, like diagram can be put or Venn diagrams or flow charts, connections, points, paragraphs, many other things can be used. Then see, these are all related to how answer writing should be done. Now with respect to adhering to certain things which are recognized as like good steps in answer writing is always adhere to the word limit. This shows some personality of yours. If they say 150 words, your answer should be within the limit of 150 words. Okay, or if it is 250 words, it has to be within the limit of 250 words. You don't have to literally count them in the exam. If you start counting, you will be falling short of time. While practicing it, count 1 or 2 times and you will get a rough idea. Okay, if I write 1 page, in 1 page my rough words are so and so. If I write 2 pages, it will take care of this, or 3 pages, it will take care of this limit. Accordingly, you will get it. So word limit is one important aspect, and this shows that how good manager you are, like time management and content management. Then here many of the people like they think like 150 means 2 pages are there, I need to fill all 2 pages. No need for it. Here also you can be smart and say writing above average to good answer, like a good to very good answer is better than writing excellent answers. Why I am saying it? If you write good or above average answers also, you will be able to finish entire paper, all the questions. But if you start emphasizing on excellent answers, what will happen? You will be left with some questions and you will miss out completely. That will have a serious implications. You should not leave any question in the mains. So this is where you can go in the plus or minus 10% range of it. Like if a question is being asked for 150 words, you can write it in 130 words or 170 words, accepted. But try to keep it in the lower limit. Try to complete it in 130 or 40 words. Don't have to fill 2 pages. Write it 1.5 page or 1 page, 75% of the another page. Rest you strike it out. So save that time, and that can be used in some other question. So no question will be left. So just because of that, maybe in one question you might be getting 0.5 marks less than what you would have got earlier. But that is also giving you scope for writing 2 or 3 questions where in each you may get 3 to 4 marks, like 12 marks boost is there. Okay, so this is how you can manage it. Okay, so this is for answer writing, particularly those who are not able to finish the paper within the stipulated time, you can practice them. Okay, now let's go into the next two type of landforms, which are karst landforms or karst topography. Okay. Please write it, karst topography. First of all, let us see what is the meaning of this, and then we will see the various types of landforms that are created. Okay, please write. Karst is a landscape which is underlain by limestone or dolomite, which can easily dissolve in water. So as it is dissolving, it can create some erosional and depositional landforms. Okay, and the name, like karst name, has been given because there is a province in Yugoslavia where this kind of landforms are created, landforms are found, because that is where high amount of limestone and dolerite was present, and initially this kind of things were being found. So based on it, same name has been given, and now all over the world we can find it. For example, in Andhra Pradesh there are Borra caves, in Gokarna if you go, there is a very big location, and Guna caves, okay, recently they got highlighted. All such ones, they are good examples of karst topography, how underground water has resulted in various features. Okay, so please write next point. It is so named after a province in Yugoslavia on Adriatic Sea coast, where such formations are most noticeable. See, again here also erosion can happen, deposition can happen. As a result, we can have erosional or depositional landforms. First let us understand, then we will write it. First learn. See, let us say there is a region, and this entire region is filled by limestone. Here limestone is there, entire thing. Now let us say on the surface there can be water, and this water can sink because it can dissolve, and it can sink into the underground, and in the underground also it can erode, and it can create big hollow structures such as cave. A cave can be created because continuously erosion and dissolution and transporting the material can create a cave. So one of such erosional feature is underground cave. You can see it here. Some of the movies, like treasure hunting movies, also you can see such caves. Okay. Then the second thing is arch or natural bridge. Now here the cave is there, and further erosion could happen, and slowly if this increases and the cave becomes bigger and bigger, there comes a time where this entire location is eroded, and we have this portion is removed, only we have this portion left, which looks like a bridge or not? True? this entire portion has been removed. Let's imagine this entire room, classroom is filled with limestone, and if a small material is removed, it will create a cave. Let's say this entire thing has been removed from here to there, this entire one is hollow. So somebody who is standing there and looking at it, to him or to her, it appears like there is a big arch, natural arch created. So this kind of arch can be created, particularly when part of this cave collapses. Like see, here the hollow cave has been created and portion of it collapsed, that has given rise to this entire arch like structure. Your good name? Aditya. Aditya, go wash your face, you are feeling very sleepy. Come, go wash and come back. Right, this is arch or natural bridge. Okay, then let's say window bridge, the action is done by the wind and on the rocks. Okay, here this action is done by underground water on limestone ridden earth surface. So these arches are inside the earth, and when the cave collapses, that is when they get exposed. Okay, as if an arch has been created. See, can we make something like a cave? Just imagine this room itself. Let's say there is a hollow portion which is here, you have a hollow portion which is cut. This is what we are calling it as cave. Now let's say this portion got collapsed, this particular portion got collapsed, cut. So it will open up, this side and that side it will open up, and only some structure is left that appears like a cave, arch when the cave collapses. So that is what natural arch. Okay, then the next one is arch, next one is sink hole or swallow hole. Generally these are on the surface. Let's say here water is sinking and slowly here it might create a depression and a big hole can be created through which water is going to sink. Here you can see this entire, and the water is entering into it. So such surface, on the surface ones are called sink holes. Now when the sink hole collapses, let's say this gets collapsed. Okay, it appears like, see here on the surface, let's say my hand is the surface and here the hole has been created, and whatever the surface water is there, that is disappearing through it and entering into the underground. Now this particular portion gets collapsed. Now this opens up a kind of a window. If you are from the outside, you can look at it as a window like this. Such a kind of window is what we call it as karst window. See here you can look at the 3-dimension one. In the very beginning I have given this. Here you can appreciate it, like this is the front view of the 3-dimensional one. Here there is a sink hole where the water is sinking and going into the underground, and here it can create a big hollow one which we call it as cave. And let's say this cave is becoming bigger and a portion of it gets collapsed. So this will open up and here there will be this structure from this side to this side. 3-dimensional, that's why I am curving it. So here if you look at it, this portion like here to here, the surface portion, it appears like it's a kind of a bridge connecting this, and rest of them is got collapsed. So that is natural bridge or arch. Okay. Then one more thing is, let's say when this sink hole collapses, so if you are here, it appears like there is a window created. Earlier it was a hole, from the surface it was a hole. Now this got collapsed. So from the surface it appears like there is a window where you can see the other side of it, or from the inside you can see the out. From the inside the cave or inside the underground you can see that is the exit or door or a window you can say. Okay. So that is what we call it as karst window. Apart from that, these are all erosional ones. Then there are also some depositional landforms. Okay, in many places or in many movies you might have seen this kind of vertically outgrowing structures from the top as well as from the bottom. Okay, see why it happens. These are called stalactites and stalagmites. The bottom one is called stalagmite, the top one is called stalactite. So how it happens, let's say this is the top of the surface and this is a cave has been created. Now within the cave, when the water is sinking, let's say from the surface water is sinking, and that will have the dissolution of calcium carbonate. So lime water it is actually. So lime water, let's say from the top, drop by drop it is falling. Okay, drop by drop it is getting accumulated on the surface here, and a drop is getting formed first and then it is falling. So when the drop is getting formed, in that process it is taking some time, and in that time some amount of calcium carbonate which is dissolved can get deposited. Possibility is there, some evaporation could happen and some amount can get deposited. So small portion is deposited, then whatever the water is there that dropped. Similarly another drop, another deposition, another drop, another deposition, another drop, another deposition, and as the time progresses it can lead to vertically growing structure from top to the bottom. So this kind of structure is what we call it as stalactite. You can see this. Here water droplet with calcium carbonate is slowly coming one by one. Okay, you can look at this mechanism in order to highlight it. See, as you can see, as from the top you notice it, okay, not from the bottom, as from the top that water is getting dropped one by one, and in that process slowly deposition happens and there is a outgrowing of calcium carbonate based structure from the top. So such kind of structures are called stalactites. Now let us say water which is falling from the top is going to fall at the bottom and hit the surface. So there will be friction, and at that time there will be some small deposition of calcium carbonate at the bottom as well. Like each time when a drop hits at the bottom, it is going to have a small depositions, and as the time progresses slowly these depositions will also start growing from the down vertically above. Such outgrowing structures from the bottom is called stalagmite. Now as the time progresses, like let us say from the top also there is a outgrowing thing, then the bottom also there is a outgrowing thing, and then after some time both of them may connect. If the such connection happens, this is what we call it as a pillar. This is going to provide extra strength to the cave which is got formed earlier. You can see here a pillar has been created, here the pillar has been created, here stalagmite is there, stalagmite, stalactite, stalagmite, stalactite, such things. These are all depositional ones because there also deposition happening, here also deposition happening.
Similar to this, there is a raw melting rock.
Melting?
Melting rock. It is also due to the content of limestone.
Where melting rock is happening?
I
That depends upon the what is the mineral composition of that rock.
know the content limestone.
It can be like limestone is easily dissolvable in water. Dolerite is also like dolomite is also limestone with some percentage of magnesia. So it can be easily dissolvable. Whatever that is dissolvable then can have these formations. So this is all about the depositional landforms. This takes care of entire the karst landforms, both erosional and depositional. Clear? Those who are in the live? So let us write them, then we can wind it up. Okay. So please put erosional landforms. First, cave or cavern. Cave or cavern. Please write, this is an underground cave. This is an underground cave formed by action of action of formed by what we have written, formed by action of water in which limestone is dissolved. In which limestone is dissolved. Okay, see how we can present it. Like let's say this is a topography. Here you can make a big cave with some structures could be there, but you can write it as cave. Next, arch or natural bridge. When a part of the cavern collapses, the portion which keeps standing forms an arch, so we can present it like this is the arch. Next, sinkhole. These are funnel shaped depressions on the surface from which water sinks to underground. We can make a depression on the surface and say this is sinkhole. So from here the water may sink into it. Okay. Next, karst window. When a number of adjoining sinkholes collapse, they form an open broad area called karst window. Next, depositional landforms. Within that you can write stalactite and stalagmite. First we will write about stalactites. Stalactite, please write, it is a vertically down growing structure from the roof of a cave down growing structure from the roof of a cave due to deposition of material, due to deposition of material. So you can draw roof and you can show the vertically growing one. See, people get confused between stalactite and stalagmite. Just remember, in stalagmite G is there, G for gravity, gravity means earth, niche. Remember like that, stalagmite means from the bottom. Next, stalagmite, please put the heading, stalagmite. It is a vertically upgrowing structure from the bottom directly below the stalactite. This is also due to deposition as the evaporation happens. Then next one is pillar. Pillar, please write. When stalactite and stalagmite join together, when stalactite and stalagmite join together, they form a complete pillar known as column. You can call it as pillar or column. A complete pillar known as column or simply pillar. Draw these three. Done. Now, I have already explained the mechanism of it. Okay, so that's how they are created. You can see the outgrowing structures of them clearly. Okay, now you can take one question for answer writing. Explain the role of wind in creation of arid landforms with examples. Okay, so this you can approach both depositional and erosional landforms can be given, and try to draw diagrams as well with the examples and other things. Okay, now with this these landforms are created. Now we need to cover only marine landforms, plateaus and lakes. If that is done, then geomorphology is done. Like within 10 sessions geomorphology is done, then climatology and oceanography. Then we can go and discuss Indian geography and economic geography. That's how we can proceed further. Okay, so let's wind it up here. See you tomorrow. Okay, if you have any queries, those who are in the live, just give me confirmation or the points are clear. Saloni, Akash, Lakshay. Here, any queries? Those who are here, all the things are clear. Okay. Okay, then let's wind it up. Bye.